So it was brought to my attention that there was two slides that um, I thought I went over, but somehow it didn't get recorded. And so you are responsible for this information. These both come from chapter 18, and hopefully you can go back to your notes and find these slides and know that I meant to lecture on them. Somehow there was an issue with the recording. So um, properties of amino acids, this was from chapter 18 in the first video lecture. An amino acid is a molecule that contains an amino group and a carboxyl group. And you may recall that carbohydrates existed as the L and D forms, and I taught you how to figure out which one it was, but that all naturally occur in monosaccharides, or at least most of them occur as the D isomer. Well, as it turns out, all naturally occurring amino acids, those found in your body, are the L version of amino acids. So you're going to want to know that. Also, you're going to want to know what an amino group is and a carboxyl. So an amino group is an NH2 or NR2, NR3, NH3, that sort of thing. It has an N with substituents on it, but it can't be a carbonyl group because y'all know with a carbonyl attached it would be an amide. But so think of an amine and a carboxyl group. Think of the group that makes a carboxylic acid what it is. So C double bond O, OH. So you may want to go back to your organic chemistry lecture to make sure you understand and know those functional groups. An essential amino acid is defined as an amino acid that has to be obtained from your diet because your body cannot synthesize it in sufficient quantity. So you still need it, yes, but you have to eat it and ingest it in order to obtain it. So your body doesn't have a de novo synthesis or a biosynthesis of it on its own. So it comes from your diet. You don't need to know this, but the essential amino acids are phenylalanine, valine, threonine, tryptophan, methionine, leucine, isoleucine, histidine, and lysine. But again, you don't have to know that. I just wanted to get that out there in case anybody was interested. And a Zwitter ion is an electrically neutral compound that contains both negatively and positively charged groups. So on one molecule you might have a negative charged end and a positively charged end, and the sum of those charges is 0. So that is a Zwitter ion, and many amino acids at physiological pH have Zwitter ions. Okay. Yeah, so in the previous slide, I accidentally said that amino acids contain Zwitter ions, but rather, properly said, amino acids can be Zwitter ions at physiological pH. And so moving on to this slide, this was found in the video lecture part 2 of chapter 18. And so a cofactor is a non-protein component of an enzyme that is necessary for an enzyme's proper functioning. Okay, let's contrast that with a coenzyme, which is also called a cofactor, but it's an organic molecule. So a cofactor in general would be like something that makes an enzyme work correctly. Not all enzymes require a cofactor, but some do. So in terms of cofactor, not coenzyme, you may think of hemoglobin, which is a huge protein that has 4 subunits bound together to make a quaternary structure. And as big as it is, and as awesome of a structure it is, it's rendered inactive unless it has an iron embedded right there in the middle of the heme of hemoglobin, the porphyrin ring. Not that you need to know what a porphyrin ring is or a heme, but for those that maybe know what hemoglobin is, that's what I'm talking about. But without that iron, hemoglobin doesn't work, okay, as it's supposed to. So iron would be considered a cofactor, but one thing you may know about iron is that it's an element on the periodic table. So in the heme, it's actually an ion, but it's not organic, right? Because it's not carbon-based, it's inorganic. So a coenzyme would be like a cofactor that is an organic molecule, such as biotin or others. So an enzyme doesn't work unless it has a particular organic molecule bound to it. Okay, so cofactors and coenzymes are not proteins, okay? They're just random molecules, be it inorganic or organic, that causes the protein to function. Remember, proteins are made up of polypeptides consisting of many individual amino acids strung together through peptide bonds. Coenzymes are not that, okay? They're any sort of organic molecule that's needed to make the enzyme work correctly, whereas a cofactor could be a non-protein component that's not organic, such as iron or magnesium or something like that. And a vitamin is an organic compound that is essential in very small amounts for the maintenance of normal metabolism. You're going to want to know that definition. So vitamins, you know, vitamin K, vitamin C, vitamin B, vitamin A, all these are needed in small amounts to maintain healthy metabolism to get you in a state of homeostasis. And lastly, antioxidants. It's a substance that prevents oxidation. So your body sometimes generates reactive oxygen species and other radicals that are damaging to your body. Okay, well, antioxidants serve as a reducing agent, meaning they're agents of reduction, meaning they give electrons to these oxidative species in order to reduce them and make them not as damaging, okay? And it tames them, if you will. And what antioxidants do is because they gave an electron over, they themselves become oxidized. And so it reduces one thing, itself becomes oxidized. If you have trouble understanding that, go back to whenever I talk about redox or oxidation reduction reactions in the general chemistry segment of this course. Okay, but various foods, especially berries such as blueberries, are good antioxidants, and so it's good to eat a handful of these frequently in order to help your body prevent these oxidative damaging reactions.